Hello and welcome to another one of D's ADD videos. Today we're going to be looking at a second order differential equation example with a repeated root. So step one, you got to find your characteristic equation. Hopefully you've done a few of these already and you know that the power, your derivative number is going to be equal to the power of your r variable, and here no r's because there's just y there, no derivative. So then you factor this. Hopefully you can just see that's r minus 1 squared, but just in case you can't, the factors of 1 then add up to -2, -1, -1. I've seen a lot of people suffer in differential equations due to their lack of mastery of their foundations, and it comes back to haunt them, whether it's factoring or integration or whatever. Alright, so then we factor out the r that's common, and then here, because the signs are different from that, we factor out a -1, and hat over factor tells us we have r minus 1 left. Factor out the r minus 1, it's common, you're left with the coefficients of r minus 1, which indeed is the r minus 1 squared. Okay, what does that mean? That means that when you set that equal to 0 and solve, we have a root of 1 to your characteristic equation, and it's repeated twice. So how do we get a general solution out of that? Well, y would equal c1 e to the 1t. I'm going to write it there just for your benefit. You don't need to write an actual 1 there. And then plus c2t e to the 1t. And that would be your general solution. Okay? If it was cubed there, then we'd have plus c3t cubed e to the 1t. Alright? And that's basically it. It's not too bad. So again, you could be given initial conditions to solve for this, and you would need to just plug in the derivatives and the actual x or t's and y values to solve for c1 and c2. Okay? So I hope I've clarified any confusion that you might have. You need to practice, practice, practice. Thank you and have a nice day.